Okay, it says here, this graph shows the depth of the water in a bathtub at a function of time. So, what does each segment of the graph represent? So, from O to A, what does that represent? Anybody have a, yeah? I'm sorry? The bath filling up? Okay, so the tub filling up, and it took how many minutes there? That's like 5 minutes, eh? 5 minutes. In 5 minutes. Okay, what about from A to B? I'm sorry? I wouldn't say they're getting into the tub right. What happened? Yeah, they stopped the water. Yeah, so water stopped. They're probably checking the temperature, right? Water stopped for, it looks like what, 2 minutes? 2 minutes. Yeah, this is definitely like what you would be interpreting graphs like in physics. Okay, so BC. Yeah, that's getting in the cup because it's a quite a fast depth. So getting into tub, because essentially it goes straight up. Like there's no time that it really takes. It takes like in practically a minute, but it's not really whatever. Okay, from C to D. What's happening in C to D? Having the bath. Yes, having the bath, relaxing, whatever you want to say. Make up a story, I don't care. So how many minutes were they having a bath for? It's funny. It's kind of, yeah. Yeah, it's almost, it starts at a little bit before 8, and then they're done a little bit after 16. So approximately 9 minutes. Okay. From D to E, what happens there? Getting out of the tub. Getting out of tub. From E to F, probably drying off. You guys know how to take a bath. There you go. Drying off. Okay. And then what happens from F to G? Yeah, drowning. Yeah, draining tub takes how much? 6 minutes. Okay. So once you figure out what's happening, it's pretty easy to make a story for it, right? Okay, let's see the next one here. Interpreting a graph, look below. Here's Jody's height over her years. So how would we interpret this? What? So the graph shows Jody's height from, yeah, it starts at age 5, it looks like. 5 to 20 years of age. What happened between 5 and 16 years of age? Jody grew. How do you know? Well, yeah, so you could say at age 5, she is, what is she about? 110 centimeters? Approximately 110 centimeters. And the height increases until age 16. How much is how tall is she there? I think it's 170. Because it's going up by 20s, and this is halfway at 170 centimeters. Okay, what happens between the ages of 16 and 20? She kind of just stops growing, right? Stops growing. How do you know? The graph doesn't increase. The graph is constant. How tall is Jody? Yeah. Would you say 170? 170? Yeah? Okay, so it seems like people know how to. It seems kind of like this is way too easy, so don't take this for granted. You should practice a little just to make sure you're not missing anything, okay? Here is the wages and the years worked. Which person has the greatest hourly wage? The greatest hourly wage. F. What is it? Yeah, $12 per hour. Or you can just say $12. Which person has worked for the least number of years? Yeah. A. How many years? 1 year. Make sure you're putting your units because that's an error code, right? Okay, which two people have the same hourly wage? B and D. And what is that? $10. Which two people have worked for the same number of years? Yeah, C and D. And how many was that? 3 years. Okay, so pretty easy to, you just got to make sure you know what you're reading. You guys are pretty bright, so you can figure it out. It just takes a little practice. Okay, here's another scenario. The volume of gas in Winston's motorcycle. So from A to B, this graph goes, what's the blank I'm looking for? Down to the right. So the volume of the gas is decreasing. So we're trying to use some good words here, not just, you know, up or down or whatever. The possible situation is Winston starts with 15 liters of, it's liters, yeah, liters of gas. He drives for 2 hours and has, yes, 5 liters of gas remaining. Very good. So do you see how we're reading this? Yeah? Okay, so what happens from B to C? The graph is constant. That was the term. You could say the same, but the term is constant, right? It's not changing. So constant. So the volume of the gas in the tank stays the same. Okay, so what's a possible situation? If the gas didn't change, what happened? He stopped for an hour, 1 hour. And then from C to D, the graph goes up. So the volume of the gas of the tank is increasing. What do you think happened? He went to the gas station, yeah, and filled up. Okay. Describe a possible situation for this graph. Okay, I'm going to give you a second to do this scenario, okay? From A to B. I like the stretching. Actually, I saw something about somebody reading a book. I think that was you, right? Reading. Oh, getting his music ready for his run. And that was about 1 minute? That would take about 1 minute to get all your music ready to go, yeah? No, no, from B to, I'm talking from A to B. It's not going up, right? I don't know. I don't know. B to C starts running. He sprints, warms up, sprinting. That's for only a minute though, hey? And from C to D, what should we say? Constant run. Constantly. I know, it's kind of boring. Running for 2, 4, 5 minutes. D to E, cooling down. It's funny that he's cooling down for that long time, though. It takes him a while to cool down. Cooling down, but how many minutes was that? 7 to 15, 8 minutes. Isn't it 8 minutes? 8 minutes? Yeah? And then E to F, resting. Okay.